morning, everybody. This is Mr. Bedard. I just want to talk to you again about right triangle trigonometry. And I'd like you first to turn your calculators on and make sure that your mode is in the correct setting. Okay, this is important for trig, so you press the mode button. Make sure your black box is on degrees. If you have that, you're ready to go. All right. So what we said the other day, and feel free to rewatch those videos, we said that if you want to find missing sides or angles in triangles, um, we should use trigonometry to do that. And in this case, we talked about SOHCAHTOA, okay, and I rewrote that for you here. To recap, the sine was equal to the opposite over the hypotenuse, the cosine was the adjacent over the hypotenuse, and the tangent was the opposite over the adjacent. So what you should do, and in all these questions, we're trying to find out the angle. So the angle is theta, and that's that symbol that looks like a 0 with a line through it. This is a Greek letter theta, and we use that to find missing angles typically in trigonometry. So what we have to do is we have to basically label the sides. You have to label always the hypotenuse, the adjacent, the opposite, okay? Now the hypotenuse is always going to be the hypotenuse. That's across from the 90-degree angle, so in this case, that's 13. The question becomes, what's the deal with 12? Is 12 adjacent or opposite to the theta? Well, is the 12 more next to or across the way from this angle? And I think it's pretty clear that that's going to be next to. So that's adjacent. So what's adjacent in hypotenuse? That should correspond to the ka, the one in the middle, the cosine. So the way we write that is that the cosine of the angle, theta, is equal to the adjacent over the hypotenuse. When we find the missing angle, this is where we have to do that inverse. The inverse has the little -1 as an exponent. So the cosine inverse of 12 over 13 will give us what theta is. Okay? So I go to my calculator, I press second cosine, and then 12 divided by 13. And in all these questions, they want to round it to the nearest tenth. So in this case, it'll be about 22.6 degrees. Okay? Let's look at number 2. So I look at the angle that's given to us. That's going to be the theta. Let's label the sides. Now, if you look, the hypotenuse isn't given to us in this case. Okay, the hypotenuse is side AB. So you have to ask yourself, what is the 4? Is the 4 opposite or adjacent? Well, that looks like it's across the way, doesn't it? And the 13 looks like it's next to it. So which trig function uses opposite and adjacent? Well, that should be the TOA. So we write that as the tangent of the angle is equal to the opposite over the adjacent. All right, we do our inverse function to get what theta is. So I hit second tangent 4 divided by 13, and that should be about 17.1 degrees. Okay, let's go look at example number 3. So again, I look at what the theta is, what angle I want to find. The hypotenuse is 9, that's across from the 90, and the 6 is next to that angle, that's adjacent. So adjacent and hypotenuse, again, that should be a cosine. The cosine of theta is equal to the adjacent over the hypotenuse. All right, I do my inverse to get what theta is. All right, so I hit second cosine of 6 divided by 9. And to the nearest tenth, just be careful with that. That should be 48.2 degrees. In number 4, this is our angle theta. The hypotenuse is not marked. It looks like the 11.9 should be opposite that angle. The 10 is adjacent to that angle. So that's a tangent again. The tangent of the angle is equal to the opposite over the adjacent. Okay, so second tangent, 11.9 11.9 divided by 10. And to the nearest degree, all right, be careful on this one because the 5 bumps the 9, so it just should bump to 50. 50.0. You need a value in that 10th position. Okay, let's look at number 5. So from the perspective of the theta, the 7.7 is the opposite, and the 14 is the adjacent, right? Isn't this AB the hypotenuse, which we're not going to use? So we have another tangent. The tangent of the angle is equal to the opposite over the adjacent. Second tan, 7.7 divided by 14. So theta would be about 28.8 degrees. All right, and number 6, from the theta, it looks like 5 is across from the 90. That's our hypotenuse, where the 4 is adjacent. That looks like then it's a cosine. The cosine of the angle is the adjacent over the hypotenuse. So let's do our inverse. I'll do second cos of 4 divided by 5. And that should be, theta should be about